thank you very much for joining this InfoShare. I am Xavier Jeannin. I'm working in the network technologies and service development working package in GÉANT 4-3 project. And I am the task leader of the network technology evolution. And we will present today with our colleague Piotr Rydlichowski from PSNC and Susanne Naegele-Jackson from DFN some result of the work that has been made in this task. Okay, I know I received sorry, I received a Zoom pop-up that was very strange. So we will continue. So I continue. So this InfoShare will be dedicated of quantum key distributions, test, or also deployment in life. Before this, I will give you a short introduction. You can find on this different URL some white papers that has been written, some InfoShares that has been already given, and that was registered, that was also recorded, sorry, and that was also, and you find also the slide and so on. So I think it is a useful, you can find some useful information in this page, and you can download this presentation on the event, so you can get this URL and therefore look at it. We are currently working on the quantum technology training. So this is something that we do in a collaboration with GLAD team. And we have in fact identified that it's really a new field, a new domain. So there is a need to lot of I would say skill transfer. Moreover, on this subject, there is some really basic mathematical things that has to be certainly looked again. So there is different topics that we have already identified and that we are currently producing some training as it has been made already in the e-academy of GÉANT. So you will find it hopefully soon some first training at this URL. In our team, Piotr Rydlichowski is our technical leaders, and we have also you can see also some other participants that you can contact if you want to have some feedback and so on. There is also two lists that you can use if you have some questions, of course. And Susanne will lead this task during GÉANT 5.1, so you can also contact her if you have also any questions. We have also set up an open quantum group meeting because there was a lot of questions that occurs from the NREN and so on. So it's take place the first Friday of each month, and it's I would say a forum where we exchange different information about quantum in general and so on. So if you have any question, please use the Zoom chat, and so we could submit the question to the speakers. There will be at each session a question and answer session. There will be a question that could be raised at the end of each session, and there will be a question and answer and discussion session at the end of this InfoShare. So in the first session, Piotr will talk to us about an implementation of QKD line between Warsaw and Poznań, and also about the monitoring and the performance. After that, in the second session, Karel van Klink from GÉANT will give us a feedback of the QKD performance analysis that he has made in GÉANT lab testbed. And after that, as I mentioned, there will be a question and answer session that will be led by Piotr and Susanne. And with this, I am done for the introduction. If there is no other question, I will leave to Susanne the floor. She will share the first session. Susanne, the floor is yours.
Thank you, Xavier. So let's dive right into the first session. Let me give you a more detailed introduction to our speaker, Piotr Rydlichowski. He's the head of Optical Networking Laboratory at the Poznań Supercomputing and Networking Center, which is part of the Institute of Bioorganic Chemistry of the Polish Academy of Sciences. And his focus is on optical data transmission technologies and electromagnetic wave theory, and also propagation simulation. He is involved in several European QKD projects and also in the big quantum flagship project. He is also working in the Polish National Quantum Technologies Laboratory. And with all this work, I'm very pleased to say, like Xavier already mentioned, he is the QKD subtask leader for us in the GEO43 project. So Piotr, please go ahead, the floor is yours.
Thank you, Xavier. Thank you, Susanne, for the kind introduction, and thank you for all the guests to have the time to join and hear about our, let's say, advancement and tests that we did and results. Yeah, let me share my screen. Okay, you should see right now. Okay.
Yes.
Yes.
Thank you. So the first presentation, as kindly Susanne mentioned, will focus on the QKD line, a long distance implementation that we did between Poznań and Warsaw. Some results, practical implementation, and I've divided this to two sections. So in the first presentation, I will talk about just simply physical implementation. And in the second presentation, I will just focus on the monitoring and performance to distinguish these two elements and maybe not to mix because it's a lot of material. So very quick introduction to PSNC. So we are the Polish NREN. We are running HPC center and a lot of services connected to new generation of digital services, cybersecurity, future internet. And what is important, we are running a metro area network within the city, within the area of Poznań, and also the nationwide network Pioneer, which is a consortium of the all metro area networks in Poland, and PSNC is the operator of the network and owner of the infrastructure. So we have different data centers and sites and two networks, as I mentioned. And just to briefly show the NREN network in Poland. So we have 5 HPC centers and the other MAN networks that together we provide the services to our research community. And the focus here today will be the Poznań-Warsaw line, as you can see here, which is roughly in optical distance 380 kilometers, where we deployed this year and run since June this year QKD service. As you can see, also we have a lot of institutions connected to our network, different institutions that we collaborate with. And a part of that, we also run the network in Europe to connect to major exchange points in Frankfurt and Hamburg. So basically, I would like to start with some background regarding how we managed to procure the equipment and build the service itself, and what's the background of this initiative. So I would refer to, I think we all know this schematic, so the quantum activities within the European Commission, and our activity dates back to the quantum flagship time. So when still this program was run, and actually this is the time where we procured and launched the project that allowed us to use this equipment. And actually the project itself that I have to mention that allowed us to build this infrastructure, it's a National Laboratory for Photonics and Quantum Technologies. It is a nationwide Polish-funded project, which is coordinated by our colleagues at the University of Warsaw. And we have partners from the Silesian University of Technology, Wrocław University of Science and Technology, Marie Curie Skłodowska University in Lublin, and Nicolaus Copernicus University in Toruń. So within this project, we have mainly designed to run 3 laboratories. The first laboratory is focused to the National System for Generation and Distribution of Reference Optical Carriers, so we can call it an optical clock. And for the second laboratory is Photonic Technologies Laboratory, and the third one, which is important here for us today, Quantum Technologies Laboratory. And within this lab, one of the elements was to procure and launch the testbeds, QKD testbeds, for 2 elements. So for the metro area networks and for the long distance between intercity links. And why this element it's important? As you can see on this slide from our web page, the 2 laboratories, so the reference time and frequency and the quantum technologies, which is the part which is focused on the QKD line, because the quantum technologies laboratory is focused not only on QKD services, but also on the other aspects of quantum technologies. But in case of QKD, as you can see, the Poznań-Warsaw line is important because it will accommodate 2 very interesting services. So on one hand, QKD Lang, which is already running, and the second survey, which is planning to be deployed soon, optical carrier link, which is you can see this in yellow. So it's a very interesting use case and opportunity for us because we own the fiber, so we have the possibility to implement it. And as I mentioned, so we divided these activities in 2 areas. So first, to gain the experience and launch the services, we installed a metro QKD systems. So within the area of Poznań, we installed 2 QKD systems that were also used in a number of different activities and projects, which I will mention. But basically it gives us a baseline and basic experience and feel of the system and how we can use. And it was, of course, introduction to the possible installation of the long distance lines, because at the time the advancement of the technology did not allow to install the long distance link, so it was still under development. But basically the idea of the long distance line was to experiment with the QKD as an example of the quantum communication between the nodes in Poznań and Warsaw, experiment with single photon devices. And what was especially interesting for us, integrate this infrastructure with our existing network infrastructure and possibly influence the next generation QKD prototyping, which is ongoing. So within the area metro area network activities, we procured 2 different systems. One was production grade. You can see this is Centaurus 3 from IDQ, and one research system, which is Clavis 3 system also from IDQ. And also we had 2 encryptors that support the QKD interface at C014, and one dedicated discrete quantum random number generator. It's a Quantis QRNG, also from IDQ. And this set of equipment was really important because it allowed us to run a really number of different experiments before introduction and installing the long distance line. So first we did the test within the hour between the data centers in Poznań. So it's about 10 kilometers link. And then we used the equipment to also use different tests also within the OpenQKD project using the cross-border connection that was installed between Ostrava and Jeannin. And our colleagues in CESNET also together, we used this equipment to run also a cross-border trial for QKD, this service, and share with the data and time transmission services. It was also an interesting publication. Next, we showed that this equipment can be used to build an interoperable quantum key distribution network. So we don't have to use, of course, the same vendor and provider for the equipment. We can use different vendors, and using the common interface, we can mix and use different approaches to build the network. We showed this on 2021. And within the 2022, we showed also a kind of introduction of the using the monitoring data from the QKD line to using the machine learning to further enhance the possibilities of monitoring and detection of problems on the link. Yeah, it was a preliminary work. It will be continued next year where we prepare a publication. And also just recently, we also used the equipment to do a proof of concept where we integrated the QKD system with the MACsec integration. So the MACsec switches, in this case, these were Arista switches, use the QKD system to get the keys and encrypt the data and Ethernet MACsec data transmission between the switches. It's a proof of concept. So now to the main point, to the Poznań-Warsaw link. So as you can see, this metro system gave us kind of very good introduction and baseline for the next activities. And this year we procured, once the technology allowed, we procured the systems that allow to build a long distance link. You can see here, the systems are much smaller. It's a next generation of IDQ devices. They are only 1 height unit systems, so a very, very compact and low power, I would say. And the biggest point was that we have 2 links, which I will show later, that are quite demanding from the distance points of view. And this was very challenging to implement because we were not sure finally if it will be really working with the parameters that we designed and we want to show. So we deployed, first we set up and configured the system in the lab, as you can see here, and we deployed the system over 3 days on the link, on the nodes between the Poznań and Warsaw. It's our infrastructure, so it's a little bit easier to work with the implementation, I would say. One important aspect is that the QKD systems, I will talk a bit. I will talk about this a little bit later. But the QKD systems, they need to have the so-called initial shared key to start the QKD exchange, and this needs to be set up manually and physically on the devices. So you have to be physically at the device to set it up, because in the other way, the QKD service will not start. This is a security reason and precaution. Of course, it's a challenge to prepare the addressing scheme, because we have to handle a lot of different channels for the QKD service. I will show this later also. And in the first stage, we simply deployed point-to-point links. So between the nodes, we deployed QKD service, but on the second stage, we deployed a fully operational trusted node approach. So the keys were generated and relayed between the end nodes, so between Poznań and Warsaw. And the service, all the operation of the devices and all the parameters are monitored by our network operations center. And still, we are constantly adjusting and modifying the system, new software, new consumers. So in this case, new encryption interface that we can use in our activities. And on the critical links, we try to still improve a little bit in the power budget, so to increase a little bit margin to have a better performance. And the IDQ system, this generation uses a coherent one-way 4 states protocol. I will just briefly say a few words a little bit about this protocol. And as mentioned, the system has quite a large number of different interfaces and channels. So we have a quantum channel, we have a service channel, we have key management system channel, and simply management channel. So all these channels are independent. They can be multiplexed with the different traffic and with different combinations, but it needs to be really analyzed and depends on the implementation and the service that we want to provide. So at least it's very interesting to have this option. So now the scheme. So we have, as you can see, we have 5 intermediate nodes and the end nodes in Poznań and Warsaw. The lengths are 68 kilometers, the first setup. The second is quite challenging. It's 78, then 53, 59, 64, and the last segment has 60 kilometers. And as you can see, this is a trusted node configuration. So the assumption, of course, trusted node, it's a little bit still undefined word, but in our case, it's a little bit closer to reality because we own and operate the sites. So we have the control of the sites and what happens at the site. But the idea is to simply connect the Alice and Bob of the QKD devices. And then at each site internally, Bob and Alice are treated as a one KMS node, so one key management system node, which internally creates and relays the key. So we have the unique key between the end nodes, between Alice and Bob at Poznań and Warsaw. And of course, the quantum channel is single, it's a single direction transmission. So we only use one fiber. And as you can see, the device has different interfaces for the management, for the keys, and the KMS. So it's up to the user how he wants to implement those channels, and they can be concatenated and transmitted as a one service, but we can distribute them and treat it as a completely separate services. And in our case, we use 3 dedicated fibers. So one fiber is used for the quantum channel because if we wish to use the multiplexed version of the QKD systems, you will simply not get this kind of performance, because the links are too long, and the performance of the multiplex QKD systems is quite significantly lower. And then we use a dedicated fiber pair for the service channel, which is actually a synchronization channel. So why we need synchronization, I will tell this a little bit in the next slide. But the synchronization channel does not need to use the dedicated fiber pair. It's simply a data transmission channel, which can be multiplexed with regular WDM traffic. It's up to the user. In our case, in the first attempt, we did this as a separate channel, but it doesn't have to be. So just a few words about the coherent one-way protocol, which is used by the devices that we have. It's a very efficient and maybe I would say cost-effective way, because this protocol does not require to have perfect single photon devices. So we send a bunch of photons to distribute and send the keys, and we don't need perfect single photon devices and sources and detectors. The system uses phase randomized weak coherent pulses that we can see here as a bit 0 and bit 1. So always we have two pulses. One is actually carrying information, and the other one is a so-called vacuum pulse. And a part of that, we have decoy states. So to bring randomized, I would say, sequence to the whole quantum channel. So Alice generates the key using internal quantum random number generator, and using those coherent weak pulses is sending the signal to Bob, which is using Bob is using is checking the polarization, I would say, not polarization, but the coherence of the pulses, and using the delay line, which is actually a Mach-Zehnder interferometer, checks the coherence between the pulses and measures the time of arrival of the coherent pulses, and reports to Alice all the detections of the photons that he obtained, but without the information regarding the exact time slot when this detection occurred. This information is disclosed by Alice later, because Alice knows exactly what was generated, and then the protocol knows which bits, which pulses were actually key and which were decoy states. So this is, of course, one of the implementations of the QKD protocol. The other ones are BB84. But we have to remember that this is still under development and theoretical analysis, especially in terms of implementation for the system. And other protocols can be also used, and the system that our colleague Karel will show later uses a different protocol. So just a quick summary. So I showed briefly how we implemented first the metro and then long distance QKD links. We use it for various research activities. It's a possible support, this link, for our future ideas for QCI and Euro QCS initiatives connected with quantum communication and quantum computing. And we try to collaborate with vendors to find the new use cases and possible implementations. Yeah. So for this part, I think this is all from my side. Yeah. So I think we can have please free to ask questions before the second presentation, where I focus on the monitoring aspects.
Thank you, Piotr. I don't see any questions at the moment in the chat, but please raise your hand or enable your microphone if you have any questions. While we're waiting for questions, the metro setup that you had, that was multi-point as well, as I understood you, right?
Yeah, so it was used in the different configurations. I will show this also on the next presentation.
Okay, okay.
Quite short remark. If we don't have, I think we don't have at the moment questions. So I think we have a question. Thanks for your talk. What is the maximum link distance for the equipment you use? So around 80 kilometers. So the systems have 18 decibels of budget. So it depends. So the ultimate goal is to achieve maximum around 18 decibels of attenuation at C-band for the service to be operational. In our case, we managed to have this around 70 kilometer link, and it's working. But I still try to increase a little bit more the margin that we have on this link. Okay.
I don't see any other question.
Me, I have a question. If
yes, fair.
Yeah. Yes, for the synchronization link is also used to authentify I would say the consumer site, the target site, to be sure that we send the key to the proper site. Is it correct or?
So the topology is handled by the key management system that I will show in the next presentation. But in general, the KMS is responsible for the proper routing of the keys. And actually, it's up to us where we want to define the consumers. So the end nodes that want to exchange the keys, generate and consume the keys that are exchanged on the QKD system.
Okay, thank you.
And just one comment. So the system that we have uses the 1550 wavelength for the quantum channel, for the dedicated fiber. Okay, so if not, I think I can.
One question from my side, since you just mentioned that. So it doesn't have to be 1310. It is up to the vendor for
yes,
QKD
it's
equipment.
up to exactly. It's up to the vendor. And what we have right now is that 1550 band is used for the dedicated fiber system to achieve the best range. And the 1330 nanometer systems are used for the co-propagation systems. So the QKD systems that allow to multiplex the regular traffic with the quantum channel.
Okay, thank you.
So these two systems are used, and it's up to the user what he wants to use. But of course, the co-propagation system, it has a lower limit in terms of the range because of the higher attenuation.
Thank you very much.
Okay, so I will switch to the second presentation regarding the monitoring aspects. So just a short, maybe I will skip this because I already mentioned what we already have. But now what is important from the monitoring and operation point of view is that we have actually 4 different channels. Quantum channel, which is exchanging the keys between the QKD devices, and it can be used. It can be transmitted over dedicated fiber, or can be multiplexed within the existing spectrum, of course, with the limitations that I mentioned, because the quantum channel, it's a very weak signal, even in the range of -100 dB. So it really requires proper filtering, and of course, we cannot use the amplifiers over the link. The second channel that the systems are using is the key management system channel. So the channel which is responsible to align all the data which is connected with the topology and the infrastructure that we have. The service channel is required for the synchronization. Actually, it's a timing signal, because if we look back at the basics of the cow protocol that I mentioned, we see that those two signals that arrive, they are organized in a time bins. So that's why the system needs to be precisely synchronized between themselves to have the really precise information, which data arrived at which time bin. And during the system initialization, we can see how the data and monitoring channels are aligned, time bins. So the data corresponding to these aspects of the QKD link operation are aligned and maintained. So the service channel is crucial here for the operation. And simply management channel, which allows to get the monitoring data, access the device, and change the parameters of the device. So the KMS channel and the management channel, these are two independent things, yeah, and related with a different aspect of the key exchange. And all devices need to be connected to the key management system. In case of IDQ, it's called QMS, Quantum Management System, which is holding the information regarding the configuration and operation of the whole link. So as I already shown, we used simple trusted node topology, a chain of connection devices, but it doesn't have to be that way. So we can use different topologies. Point to point, we can use star topology and also ring network. And all these elements are able to be configured in the key management system. So this is the place where we configure the operation of the whole link. What is important that we have for the physical connections and for the KMS connections, we can have different topologies because these two elements are independent. So it's up to us how we define and how we configure those elements. Of course, in the case of point-to-point link, it's quite easy. It's simply in line with the physical connections, but if we have a star or mesh topology, we can configure this in a different way. What is also important is, I think I've mentioned this, that we can use separate physical interfaces for these services, or we can use common interface for all these services. It's up to you and how we envision the service to be provided. In our case, at the moment, we have a dedicated interface for these services, but we already planned the system to use different interfaces for different services. And what we have actually right now is for the consumers, so for the interface to get the keys that are exchanged, we have two interfaces, so ETSI 014 and 020. So 020 is more designed for the interoperability applications. So these are configured independently on the devices, and you need to have separate independent query to get the keys for these interfaces. As I mentioned, the system is being monitored in two ways. So one way is our network operations center simply uses its infrastructure to get all the statistics from the devices, but at the same time, we can see all the elements and all the characteristics in the key management system. What is in terms of the COW protocol that is used by our devices, our NOC monitors key, I would say, 3 parameters. So the key rate, quantum bit error rate, actually secret key rate, quantum bit error rate, and visibility, and temperatures. Why temperatures? Because the photon detectors that are used in the devices, they are cooled to around -40 degrees. So if the device is operating in a higher than design temperature, it can have significant impact to the performance of the link. So we really need to be sure to operate in the right window. In case of these devices, it's 35 degrees. So this is the maximum ambient temperature that devices are allowed to, for a longer time, to accommodate and keep the performance as designed. However, the key rate and the QBER, they really depend on the current conditions of the link. So they are really not constant. They are constantly changing and adjusting to the performance of the link, conditions of the link. Why, in my view, the visibility is very important parameter, because we can have a lower quantum bit error rate, but the visibility, which is showing the ability of the system to distinguish the signals between the single photons, if we can distinguish the interference, it really shows the current state and the conditions of the link if we are not exceeding the parameters, because we have to remember that the system does not have any power related statistics. Yes, so we really need to focus on the alignment parameters to see if the characteristic and performance is right within the window. What is also interesting that in the certain situations, I've noticed that we can see also noise from the patch cords as they leak a little bit of light from outside. They are not ideal, and in some situations they leak the light from outside. So in case of IDQ, the KMS system is it's being heavily changed right now, but the system that we still have right now is showing the basic information regarding nodes, monitoring, the ports used, and the names of the nodes. What is important is to check the status of all the links. So we have the links between the QKD nodes, but we also need to see the status between the Q and C nodes. So so between the KMS nodes. So the KMS nodes and QKD nodes are different things, because the QKD nodes are simply physical QKD nodes that exchange the keys, and the KMS nodes are nodes which have also a higher level functionality, which allows to configure the device as an independent KMS node. And we need to check the status of the link between all the layers and all the channels. And also the QKD links and the links between KMS systems, between the Q and C nodes, they have different parameters. So different key length, different number of maximal key requests. So all these elements are specified by the ETSI interface, which shows how many keys we can get in one request, how long the key should be. Of course, there is limit to length of the keys. In our case, it's 4 kilobytes right now. Number of requests, how many keys are being stored in the buffer, and all these elements are configured also in the KMS system. The example of the performance is, you can see that one of the links, actually here it's from Poznań, you can see that the key rate is changing between 150 and 2,000 kilobytes. So this is the range of the key change, secret key change. And also we can see that the quantum bit error rate, it should be around 2%. And you can see that the range in a normal operation, the mean value is around 2%. And of course, the visibility, I think we have, sorry, we have on the slide 2 times Cuber, but in the visibility I will have on the other slides. The visibility should be as high as possible, so around 100% if possible. So here I overlaid a little bit the data, and you can see that, of course, the limit of the performance is the limit of the weakest node, the weakest QKD link, which in our case, around 1,000 kilobits, because this is the longest link, and of course, the longer link we have, the lower the performance we get from the system. But even though we are still looking at the performance, I think it's pretty good looking at the distance that we have to travel. The Cuber is for all the links around 2%, and the visibility, as you can see, it's 99%. It's very good for all the links to assure stable operation. What I wanted to show here, I know it's a very small font, but I wanted to show here that actually displays. So just to show that the system is constantly adjusting the parameters to achieve the highest possible visibility and lowest possible Cuber. So these values, so the values and parameters of the single photon source, the source that we have, they are not constant. They are changing over the operation of the line, and that's why we have a variation of the secret key rate. And after each change, of course, the buffer of the for the keys is being filled in to get the latest keys that are used for the consumers, so the devices that actually get the keys. The length, the size of the buffer, of course, can be changed, but after specified amount of time, of course, the keys that are stored in the buffer are invalidated if they are not used. Yeah. And this is specified also using the etc request, and to specify in the KMS, actually within the KMS, we can specify how many keys we can store in the buffers. It's up to us how we define it. Yeah, so these are the crucial elements regarding the monitoring and how we implement it using our NOx services, and how we look at it from the device perspective. And what I think here, it's important that we have a lot of variation of the link of the values. Maybe I exaggerate that, a lot of variation, but we see the variation, and the variation actually, it's a interesting thing because it gives us a lot of data about the changes over the link, and then you can try to correlate this data using ML algorithms or the system that the approach that we tested with ADVA colleagues this year to adjust the value and bring the other new information to the link. So as you can see, the QKD link can provide a lot of interesting data regarding the what is currently happening over the link. Yeah, so I'm a little bit above the time. Apologies. So I think we can take quick question if they
Yes,
are.
thank you. We have people saying they have a bunch of questions even. So, but let's do have time for questions. Thank you, Piotr, first of all, for this second presentation. The first question I see in the chat is from Miko Donovan. Are the KMS nodes akin to the trusted nodes?
Are the KMS nodes? Yeah, because the trusted node as an entity needs to be defined in the KMS. Because the system, the two nodes which are on the side, they need to know that they need to, I would say, cooperate and work as a one link to provide end-to-end keys. So this needs to be provided in the KMS node.
Then we have Guy Roberts with questions. Will
Okay,
QKD work? Yeah, go ahead.
Help
Guy.
everybody. I'll ask my question out loud. So if I understood correctly, the protocol that is used in the ID Quantique is based on polarization of the photons. Is that correct?
Coherence. Coherent one way, not necessarily polarization, coherence. But I see, Guy, your question regarding aerial cables. Yeah, I think this was your.
It is. The reason I ask is around a sensitivity to rapid polarization changes.
Yeah, it may. I would say that the challenge here will be the change. The challenge will be the change of the parameters of the link.
Right.
But it should work. I didn't test, but the test initial approaches that I made that should work. Of course, we don't know the limits. Sure. We have to test with the new generation of devices because next year, of course, we will have the new generation of QKD devices. So new things to test. Yeah.
Okay. Thanks.
Another question by Emir Dervisevich. Do you happen to know what is the average size of key generated by the QKD process that is in each QKD protocol round?
Protocol round. So it depends. So because of the speed, it's a limit. So in our case, the 4 kilobytes, it's a limit to the key that can be handled by the system and exchange. We cannot accommodate and use longer keys at the moment. But of course, looking lower, I don't have, of course, certain implementation elements are still confidential information from the manufacturers, either RDQ or Toshiba. So I don't have all the information. But internally, I think it only depends on the size of the buffer, yeah, because this is the main, because we need to fill in the buffer, and then based on the buffer size, we can generate the keys. Yeah. What are the physical requirements for a trusted node? Very good question, Lars. So right now there is still a discussion. What is actually a trusted node? It's a standardization issue, I would say. So that's why I said the trusted node in brackets, but it looks like that simply the trusted node will have to meet certain security requirements, how the equipment is installed, who is responsible for accessing and operation of the node. So it can bring really quite a lot of problems in terms of the usual operation. But in the end, I think what will happen is that will simply be a certain number of physical constraints to be used as a trusted node. But the ultimate goal is to simply avoid the trusted node, to exchange the range of the key, the range of the QKD transmission, to have the end-to-end transmission for a single system, and not to have the requirement to use a trusted node.
Okay, thank you. Yeah, it was exactly your comment about the rack installation and the control over the site and so on, because in principle you can, with the experiment you have done here, you can reach any point if you have a correct distance between the amplifier pops and you have the fibers. But if you don't control the access to the site, who can go in, it was more if they wanted to do, I can't remember we have some key servers belonging to a service that we are providing, and those servers will self-destruct if you are shaking the rack and so on. So it's more if the QKD vendors are looking into making them tamper-proof for physical access, and that's another way to go to maybe strengthen the trusted node scenario.
Yeah, exactly. So this is actually right now the weak point, I would say, of the existing QKD implementations, and that's why it's there is a strong push to have a longer distance QKD to avoid entirely, but your comment, Lars, regarding the focus also on the trusted node, it's also being discussed within the Etsy works. Yeah.
Thank you, Piotr. Thank you.
Guy, go ahead.
I'll try and explain my, I didn't explain it very well in writing, but if you have a quantum key service and at a particular node, you have multiple customers requesting keys, how do you manage individual keys for individual customers? And how do you ensure that one customer won't request all the keys and then there's no keys left for others? Because if you've got a limited key rate. Yeah,
so what it's done by configuring different, let's say it's called consumers. So consumer, it's a separate entity in the key management system that shows consumer pair, of course, shows path where the keys should be exchanged between which nodes, and they are completely independent from each other. They can use different Etsy standard interface, different name, and you need to use separate certificates to access these consumers. So yeah, of course you can use the same certificate, but of course it's not secure way. But in reality, you need to configure separate certificate scenario to use. I think I didn't mention this earlier, but all the elements that we talk about here, so the consumers, and then they need to have a set of certificates to access the device. Yeah.
Right.
You need to generate certificates to connect and use the equipment, and different consumers use different certificates.
Right. And then in terms of buffers, do you buffer per consumer? Is that way, or is this?
It's a per KMS system.
Right.
So the KMS system as a whole has a large, I would say, buffer, but you can also specify for a given consumer pair the number of stored keys at the given moment.
Okay.
So, for example, that your buffer should not have, for example, 100 keys at the time.
Is this what you're talking about? Is this described in a standard somewhere, or is it just a general implementation?
No, it's written in the Etsy 0.14.
Okay, so it is defined in 14.
Yeah.
And what's the
but
status
of course,
Etsy 14? Is that ratified, or I guess they never?
No, it's still under work. Yeah, in terms of this, in terms of standardization, there is really a lot to be done. So regarding the Etsy 0.14, I think major points are there, but some still elements are still missing. So over the next, I think, a year or two, the situation will clear. That's
very helpful. Thank you for that. Good answer.
Any other question? I don't see another one, but I have a small question. From a practical point of view, when it comes to monitoring in your organization and the visualization, do you have this completely separate on two different monitors, like the quantum key exchange visualization and the typical NOC visualization of the underlying infrastructure?
It's a common system. So we have, our NOC has integrated a lot of services to one management system, and simply we have messages from a certain that are triggered by certain events. We have thresholds for QBER, for key rate, and for divisibility. And when the thresholds are exceeded, the system monitors. But we have also dedicated server, which is only running KMS and showing the statistics from the devices. Yeah.
Okay, thank you very much. So if there are not any more questions, I think we're at the end of session 1. Xavier, do you want to do a small break?
Yes, let's have a 5-minute break to take a coffee, and after that we come back.
So before we move, let me just inform that there will be an interesting event in Madrid in December. It's an event that will take place after the Open QKD General Assembly, and since the project is concluding, we are organizing a workshop, open workshop for all the interested participants regarding QKD technologies, and especially in the view of the QCI. And there is already at the website detailed agenda of all the talks, so we can join it online or physically. So I think it will be a very interesting event, especially in view of the QCI activities that will start next year.
Okay, thank you, Piotr. Thank you.
Yes, so I think, Xavier, we can start the. We can move. We can move to the next presentation, which will be given by our colleague Karel van Klink. Karel is holding a bachelor's in technical computer science and master's of internet science and technology at the University of Twente, and he was working within GÉANT on a specific project which was connected with the QKD system testing, and he will show us the results from the Toshiba system that he investigated and tested. Yeah, so thank you, Karel, for joining us, and the floor is yours.
Thank you. Thank you for the introduction, Piotr. I'll get my screen share going, and then I would like to share on the work. Is this visible for everyone?
Yeah, you can. I think, Karel, you can take the time as much as you need, because we have a Q&A session, so mine was a little bit longer, so take your time.
All right, very well. I'll get going then. I performed my master's research with GÉANT over the course of the past 10 months, and where we evaluate the performance of quantum key distribution in the GÉANT network, and specifically looking into the possibility of multiplexing QKD material with data waves onto a shared fiber, looking into the possibility of such an implementation in the GÉANT network. So then, for the equipment that we used for QKD in this research, this was done with the equipment that is offered by Toshiba. And as Piotr already mentioned, this Toshiba equipment makes use of a different protocol. They call it T12, which is based on the almost ubiquitous BB84 protocol. And we look into the possibility of having this Toshiba equipment generate quantum keys, which are then used as input into Ethernet encryptors in the network, such that the traffic that flows through the network can be quantum secure, hopefully. And in this research, we first looked at the current state of standardization and also certification. So we have a literature review where we also touch upon required hardware and software, what is currently available and what is still, well, let's say, missing at the moment. And secondly, the methodology also consists of a series of experiments. Like I mentioned before, we investigate the performance of the Toshiba equipment we had on loan for a span of 2 months, where we performed some testing in the Cambridge lab at GÉANT. And we also specifically look into the possibility of multiplexing QKD and data waves onto a shared fiber. So then for the literature review, we look into the current work on standardization, specifically for architectures of QKD networks as well. Standardization for QKD hardware and for software, both for the control and management, but also for the monitoring of a QKD link and a QKD network. And in conclusion of this literature review, we also touch upon some future work that we are looking forward to. And then for this literature review, we find that existing standardization, and this is something that Piotr also mentioned in his presentation, this standardization, they currently consist of recommendations only. There are no hard set industry standards that vendors must adhere to. And as a result, implementation is largely left up to vendors on how they want to perform QKD and also have this incorporate with other optical transmission equipment. And we also find that no QKD specific certification exists yet. There is a draft industry standard from the ISO expected to be available somewhere in the future. This is still a draft. And in one part, this will work on certification of QKD equipment itself, but also a piece of, or a document for certification of QKD implementations is expected as well from this same organization, which should also specify how a trusted node is to be implemented, which is something we are very much looking forward to. Then we move to the experimental part of the research. On the right, you see a picture of the test setup we had in the Cambridge lab at GÉANT. And at the bottom, the Toshiba equipment, the QKD equipment, and at the top, some fiber spools and optical attenuators that allowed for introducing various levels of attenuation onto the fiber where we perform QKD. And so to reiterate, as we look into the multiplexing of QKD and data waves, we have the QKD in the O band, so that is centered around 1310 nanometers. And we have data in the C band, as it also is in the GÉANT network at 1550 nanometers. We then multiplex data onto this shared fiber and introduce this data at multiple power levels, multiple levels of launch power. And for our results, we look into the secret key rate and the quantum bit error rate, or the QBER. And then we also investigate the maximum sustainable attenuation of such a system. And these results are then used to evaluate a potential implementation of QKD services in the GÉANT network, where we look into which link spans could potentially be covered, comparing that with these results. For the lab setup, it is relatively straightforward. In the middle, at labels C and D, we have our means of introducing attenuation, and on both sides, QKD boxes, Alice and Bob. The key material generated by the QKD boxes is put into 2 different servers where we can verify proper operation. And this is also at labels E and F, where we introduce the data waves onto the shared medium. This is done with the Infinera Flex ILS system, which is also used in the GÉANT network. And that will allow for a realistic comparison of what kind of performance we could expect to see in the network. Then starting with a single data wave, for our results, we noticed that when data is launched at a power of 0 dBm or 3 dBm, compared to having no data waves present on the fiber, there is no significant influence in both the key rate and the QBER, which is quite a fortunate result to see. However, when we move on to the higher launch powers for data waves, for this we introduced a second data wave, we do see as power is increased to higher levels up to 15 or 17.8 dBms, there is a noticeable influence between the launch power and the key rate and also the QBER. So we see that as launch power increases, secret key rate decreases and QBER increases. From these experimental results, we gather we gather a few hypotheses. So for every +3 dBm increase in power, we hypothesize that secret key rate goes down by approximately 15% and Q-ber goes up by 6% relatively. And it is also found that the maximum sustainable attenuation was found to be 23.5 decibels. And it is estimated that in case of a fully occupied C-band, so when we have a C-band that is completely filled with data waves, we expect to be able to sustain a level of attenuation of 22 decibels. Now, with these results, we move to a feasibility study, so to say, of an implementation where ideally we multiplex QKD traffic at 1310 nanometers in the O band and have data reside in the C band at 1550 nanometers, as this would largely or greatly reduce the cost of such an implementation, as no additional dark fiber capacity is needed. For links that cannot be served in this way, we also look into the implementation where dedicated dark fiber is used with QKD at 1550 nanometers, so that is in the C band. And then there are some remaining link spans that need to be served in a completely different manner. Now, for the feasibility of this implementation, with the results that we gathered, we estimate that approximately 30% of the GÉANT of the link spans in the GÉANT network could be multiplexed with data waves and have QKD performed in the O band. Now on the right, you can see a histogram of all link spans in the GÉANT network. And the vertical green line, I do now realize that it is slightly thin, so I hope it is visible for everyone. But everything on the left of that green line, which is approximately 30%, we expect on these link spans to be able to offer QKD services multiplexed with data waves. And if we were to make use of the long-range equipment that is currently also offered by Toshiba, we estimate that up to 90% of the link spans could be used with QKD being performed in the C band. However, I should note that this is based on figures that Toshiba have provided us with. So to be able to verify the performance of up to 90%, we would need to perform additional testing. Now, for the implementation of such a system, like I mentioned earlier, it might be favorable it is definitely favorable to make use of the multiplexing of QKD and data onto the same fiber, but it is also recommended to perform an incremental rollout of such a system. So for this, we also look into the deployment in, for example, the Western Ring. Here we have similar percentages in the possibility of deployment, where here for multiplexing, the percentage goes to 23%. And then on the right, we have a map that shows all of the link spans in the GÉANT network, where the green spans could potentially be covered with a multiplexed approach. The link spans in orange would require additional dark fiber, but could then potentially be covered with the use of their long-range equipment, and the red link spans would require alternative approaches as of right now. Especially one interesting link span to note is between Amsterdam and London. You see a long red link between the going under the English Channel, which is a submarine cable that has an exceptionally high level of attenuation. This could potentially be bridged with alternative solutions such as free space QKD or perhaps even satellite QKD, but this was left beyond the scope of the research. And then we draw a series of conclusions, namely that hardware support is largely present as of right now. However, standardization is still lacking at the moment, and as a result, available software is not up to the task. The research also concludes on a list of recommended next steps. Firstly, it is recommended for GÉANT to implement a field trial link where we can investigate the real-world performance and also investigate the long-term reliability of such a system, as it is still largely unknown, especially combined with the optical equipment that is used in the GÉANT network. And on top of this, it is urged to track the ongoing standardization efforts, as this will allow for a higher rate of interoperability, so to speak, between equipment from different vendors, and also in the future will allow for certification of a proper deployment of QKD and QKD networks. And that, for my presentation, is all I have for right now. Thank you for your attention. And if you have any questions, I'm more than happy to answer them also during the Q&A we'll be having after this. Thank you.
Thank you, Karel, for excellent presentation, a really good insight to the test that you did in the lab. Yeah, so I think we can, if there are quick questions before the Q&A, please free to ask. Okay, I don't see right now the questions, so I think, Susanne, we can move to the Q&A session. Will we?
Piotr, just one minor question.
Yes, yes, Grosz.
The single photon laser you have, can you tune it to any wavelengths or for the QKD channel? I assume that you produce single photon or not. Do you hear me?
Yes, Grosz. So I can tell you how it is implemented in case of the IDQ devices. So it's not a pure single photon source, because these would require different device, much more expensive. So what is actually done, it's a very weak, it's a laser which is strongly attenuated. Yeah,
okay.
And so that's why it is tuned, the source is tuned for a specific wavelength.
Exactly, but okay, just sometimes actually confuse me because when I'm thinking about quantum, then I'm thinking about a single photon transmission, and when it is not, so it make me a little bit.
So the data, yes. So the data is encoded on the photons, but it uses a bunch of photons because it's connected with the protocol that is used. Yeah. Okay. But yeah, we need to have this we need to remember that pure single photon sources and pure single photon devices, these are different things, and they require different handling and implementation. But either way, in terms of the protocol transmission, yeah, we still use the quantum effects to provide and use the data.
Exactly. But the term quantum is used here actually based at because you are using the quantum principle for the transmission, or the protocols are you using based on the coding, the quantum coding, or?
I would say that we can call it because we simply have to count the photons. So if you look at how the system aligns, it needs to check precisely and have enough number of photons in a specific timing. At least this is for a cow protocol. In QKD, in VB84 protocol, it's a little bit different. So this is one element, but on the other element, the keys generated within the box, within the ALICE, they use the quantum random number generator also. Yeah, so these two elements connect, and that's why we can. Of course, there is long discussion if we can fully call it a quantum random number generator or source. But I would say it's a more physical discussion. Yeah. I would say another level of discussion.
Of course, yes. Thank you.
Yeah, but your question, Kurosh, it's valid. So we need to have a clear understanding how does it work, and what are the differences between the different implementations. Yeah.
May I have a comment about this?
Yes, Thomas, please.
So, hello, I'm Tamás Kis from Budapest. It was very interesting this whole afternoon. So thank you for being able to attend. On the SCAL protocol, how quantum it is or not, I think this question is a little bit debated in the literature currently. So from last year, my colleague who was a PhD student with Marcos Curti, and they had a paper where they asked this question in a very precise manner. And so it's a little bit debated. I wouldn't say yes or no at this point. I can put the reference in the chat if you like of this paper from last year.
It will be very helpful. Thank you.
Okay,
yeah, thank you, Tamas. Exactly. It's also exactly as Tamas mentioned, from the theoretical point of view, all it is being discussed, still discussed, because we, as Karel mentioned, we don't have any certification. Yeah, so and certification would require to have proofs, hard proofs of the security of different solutions implementation. And one of the challenges with the certification is that we need to certify not only the protocol but the whole device. So it is quite a challenge. We are not only certifying a new algorithm to encrypt data or to send the new QKD protocol. We need to certify and prove the security of the whole device. Yeah, that's why it's challenging. And also regarding Kurosh, your question about the quantum nature, I would say that's why also there is a significant effort to the QKD protocols that will use entanglement-based transmission. So we'll use the entangled pair of photons to establish the links and use it for data transmission. Similarly as for quantum internet, I would say, where simply entangled pair of photons will be simply a commodity that we use in the network. And also within the GÉANT, I think we can mention that there is also a plan to do an initial test of the entanglement QKD devices. It's a joint effort with our colleagues from Toshiba, a proof of concept system. So please free to ask any other questions or doubts, so we can feel free to discuss.
Yes, I would like to ask a question. It's more about the service itself and the take-up of commercial providers. Now Toshiba is making boxes that is doing this. And there, as we talked about before, there are challenges maybe for the trusted nodes and the security of the sites and so on. How is the Enron world positioned against mega providers like, let's say, Google or Amazon or people like that in the commercial space? In principle, they could buy as many boxes as they would. They could buy the fibers and they could buy new huts and so on. Is the Enron world still on bleeding edge, or do you see any uptake from commercial providers?
I would say, I'm not sure if anyone wants to, apart from me, to answer. If not, I can do it myself as a first person. In my view, I would say the biggest challenge from the commercial point of view is, Lars, that it's not standardized and without any certificates. So no client. So we can think of use cases, we can think of the application scenarios, but when we cannot use it for in a certified environment, for them it's not a value, yeah. Because they cannot guarantee and push the service which does not comply with given scenario. So that's why right now this standardization and certification is so important.
So it seems like everybody is at the same position right now, waiting for standardization. And
yeah,
And the NRENs are still playing a role in this, and as
I would say, yes, I would say
partner for the commercial providers of the equipment.
Yeah, I think the NRENs are a very good partner in terms, especially now, if so many of us are engaged in the QCI. So we will have the access to different use cases, application scenarios, and actually right now what the whole quantum communication and quantum internet as general, I would say, what it really needs is very good and interesting new application scenarios, use cases to show the exact benefits in these scenarios. This is what I think right now is a little bit lacking to, of course, we still need a lot of development. It's still early stage, but we as community, which has access to a large number of different users and use cases, really, we really have a very interesting approach, and I think the vendors value this, and especially you can see on the things that we presented here that it's really a value for the vendors, because without us, without the access to different users, they will not be able probably to do it on a such scale that they have it right now. So I think this is interesting point here.
Thank you. Thank you. Sounds good.
Any other question? Piotr, how is it for the computing centers in Poland? I mean, the laboratories that did the QKD exchange, is the whole process still very static as in a test phase, or is it can you automatically add a new consumer, for example? How static or automated is the whole process?
Yes, it is. We are using different configurations for the system. It's quite flexible and easy to change, with only one remark. And this is why I specifically mentioned this initial shared key. The challenge is that in certain scenarios, you need to, if the configuration changes of the system will require to set new initial shared key, because it will treat the system as invalidated, and you need to set it as a next time. And it's, of course, it's a physical process, so you need to be at the device pair and exchange the, actually you generate a very specific file that physically needs to be transferred between the devices. So in some cases, it really can slow your progress, because you will need, so what I try to do is to implement as universal configuration as possible that will not require the ISK change later. But in some cases, it's not avoidable. So it will slow us down.
Okay, thanks. So in your case, it was all people that you knew that you exchanged keys with? I mean, even with that initial procedure, or how was the authentication process?
So what we did for the first time was the exchange between the data centers here in Poznań, and when we started to implement the line between Poznań and Warsaw, what we did as a first step, we tested the QKD performance over this critical link, which is the longest one, just to be sure that it's running now. And it was the last node between Warsaw and our colleagues from University of Warsaw Faculty of Physics Laboratory. It was a quite challenging link, and together we established a service to test if it will operate in a desired way. And the setup is actually quite simple, because you just only need to you use a script-based approach. So everything can be configured in a script. You load it to the key management system with only one exception, certificates. It's really challenging because you need to certify the whole element and the whole system. So you need to prepare and be sure that your certificates are correct to operate it. So it's a challenging, maybe not challenging, but the time-consuming element of the whole configuration, etc.
Oh, thank you very much. Any other questions?
Yes.
Go ahead, Guy.
I guess you've only had this system installed for a short while, but I'm wondering if you've got any lessons for us in terms of operating the system, in terms of stability, its ability to operate continuously. Does the key rate change over time? Maybe with temperature over the seasons? I think these systems have to have an alignment phase, and do you ever find it gets out of alignment and you have to restart the alignment? What's your experience?
So once the system aligns, it's actually pretty stable,
right?
But the variation in the key rate is normal.
Right.
We can see this. We can see this over a longer time, even over the situations where the temperature changes also. The systems that we have, they are not so sensitive to temperature variation as the previous generation. But either way, small changes can be visible, but it's good to monitor, and as I mentioned, the system constantly aligns the source to have the best possible visibility. So that's why the key rate changes. And the other thing, of course, the cleanness of the connectors, because you're dealing with very, very weak signals. You need to have very, very good quality of connectors and clean connectors. So it's best to use, at least what I did, is to use the new, of course, new patch cords. But either way, of course, new patch cords are not always clean. So you need to take it, maybe not to another level, but yeah, they really need to be.
That's interesting advice. Do patch cords come with a kind of a rating, a higher grade of patch cords which don't allow external light onto the fiber? Because
you will need to have no. You will need to have. They are so-called armored patches, but I only observed this in a specific situations. It was not very common. Only one site where we have. It's a room in a building, and it has a window. I've noticed the change, and what I did in a practical implementation, I switched the configuration. So I moved the bulb to the place where there is no light, and I left the alleys in a place where I have windows.
Thanks.
Yeah, just to be sure. But this effect is, it's really slow and only visible if you push the system to its limits. If you're still within the recommended attenuation range, actually this does not have a huge impact. But when you're at the edge, you can see, really degradation and the changes because of the effects. Yeah. I'm not sure, Karel, about your experiments with Toshiba equipment regarding the operation at the edge of the limit of the system, but I probably expect it was more or less the similar.
Yeah, I would also. We noticed a very significant influence on the connectors as well if they were not properly cleaned. I would have the occasional decrease in performance where we would only get a fifth of the key rate, and it turns out that one of your connections is not sealed properly. So that really cements the importance of using clean connectors, and also I think illustrates the kind of sensitive equipment that we're working with. But overall, once the system was up and running, I would also say it was quite stable in its operation.
Yeah, exactly.
What is the key rate compared with data rate? The relationship between key rate and data rate.
So the system that we installed allowed us to exchange 2.5 maximum 2.7 kilobits per second of the secret key rate, and of course the data rate it's another thing because it's the way how you use the keys. So in my case, the keys are used to different scenarios. So especially connected with the interface, its interface. So I don't have large throughputs. The only use case where I had a high throughput was that I mentioned with the Arista. So the Arista was connected using MACsec protocol on the 400G direct optical interface. But in the MACsec, you can set the rotation of the keys at the time. It's not fixed, so you can set it manually how frequently you want to change the keys. And my test was about 1 minute. I didn't do much test below 1 minute to rotate the keys.
Thank you. But doesn't this relationship between data key and other data rate and key rate will influence the security of the system also?
Yeah, so it needs to be, so it needs to be aligned, and it all depends on the service that you wish to use and the projected data rate and requirements. Actually, it was one of the studies that was conducted by the European Commission to check which services will require which key rates. For them, it was very interesting to know this, and they did a very long study for the European Commission to at least assume some values, what would be desired secret key rate.
Thank you, Peter.
Yeah, but it's, of course, it's significantly lower speed. So yeah, you really need to think about your use case and how you implement and how you use the keys. Of course, the keys doesn't have to be used only for the data encryption. Yeah, they can be used they can be used also for the authentication and certification. Yeah, so only once or twice. Yeah. It's also a possible scenario, and ETSI specified also such use cases in the focus group for the quantum key distribution networks.
Any other question?
Just an advertisement. So Karel has shared the link to his master's thesis. It's on the chat, and that shows the results he got for the relationship between the key rate and the attenuation. And so if you're interested to see performance, the results that were achieved, you can see that there.
Thank you, Karel. I'm sure that makes for a very interesting read.
Yeah, it's also a very interesting regarding the maybe a little side of QKD. Very interesting aspect is also quantum random number generation service. In many use cases, it's also very interesting technology and of course independent. So the QKD devices have built-in such random number generators, but they can also be used independently as a standalone device. So it looks like this service is potentially also interesting. And I was wondering if our participants can share some thoughts about this or comments. Please free to share.
Okay, so thanks again to both of you for these very interesting insights into the practical implementation of QKD. Let's now move to our last segment. I hand over to Xavier. He has prepared some Mentimeter questions for us.
There's no InfoShare without any Mentimeter, so I will copy a link on the chat if you are kind enough to connect to these Mentimeters, because it will help us to I would say select which type of topics could be used and how we could be more useful for the NREN. So I hope that you can connect to this. I will share my screen. Yeah, it is. Okay, so the question was, please pick the term which best characterized interest in your organization for quantum technologies. So I don't know how many we are still. I think we are still 30, so let's wait a little bit. So just to let you know that there is this InfoShare, there is a lot of people who join it. So I think this is still hot topics for this. Let's wait. So it is gone, and after we will we'll go to the next question. Okay, the next question is, are you in contact with quantum user groups of your community, and which one? That would be very useful for the future works, because we would like to see which works could be done, and also not also see if we're not making the same work that has been done elsewhere and so on. User group. QCI, something from user group, yes. University or academy and research. There was satellite operators. I see that there is still development. Well, we can see that there is still well, we are really focusing on, there is a lot of public operators because university, government, academic research. That would be definitively in the domain of the NREN. BCSS. Okay. Polish something? No? No? Oh. Okay, let's move to the next question. Name a high priority topics issue in your name the high priority quantum topics or issue in your organization. Is it fiber provisioning? Is it acquiring skillness? Is it provide support to your users? Do you have already some? Distance. Yeah, do you see that the reach of the quantum hardware is increasing now? Or is it still limited to 80 kilometers? Piotr?
Yes, Xavier.
Yeah, just a question. Do you see that do you think that for now in the new hardware that there is a longer reach than previously, or we are still?
Yes, it will be. So next year we will have the systems which will be capable of even 30 decibels of budget overlaying.
Yeah. Okay. Procurement of KKD. Yes, there was a question about the procurement and if we can, if there would be useful to organize, I would say, a common procurement with the different N1. Eavesdroppings, identify users' needs, quantum cross-border, quantum with time and frequency. Yes, this is something that we try to work on it. Okay, next question. Are you already planning or setting up a quantum service in your organization? I think there will be. Yes, there is 3. Yeah, 5. Nice. Six. Yes, that's very good. Very interesting. Because is it around a QCI project in the context of QCI project that the people answer yes? Or? Okay, it doesn't move anymore. So I think there is 2 questions more on after I have finished. Are you interested in coordinated procurement of QKD equipment? Wow, definitively yes. Okay, and thank you for this. And I think this is the last question. Are you directly or indirectly part of any European Commission quantum technology program? On which one? Which program you would be involved in? No. Oh, it's a big program. EuroQCI. Quantum flagship. QKD it is open QKD? Digital 2021 QCI. QCI. So CF QCI. No, it's open QCI. Okay. If there is nothing else, I think with this I am done. So I would like, if there is no other comments, I would like to thank you very much, our speaker, Karel and Piotr. Thank you, Susanne, also to help to chair this meeting, and thank you to the audience for this to join us this Friday afternoon. And wish you a very nice weekend. Thank you. Bye.